Hey guys, it's Mrs. Shefcheck here. Today we're going to be using the slope-intercept form of lines, which remember is y equals mx plus b, in order to determine whether a system of linear equations has 0 solutions, 1 solution, or infinitely many solutions. We've already done some work with graphing these, but today we're going to see how we can figure it out without having to graph them, just by analyzing the equations. Before we get into the problems from the book, we're just going to take a minute to update this notes page. So you should already have this glued into your notebook, but what we're going to do is we're going to add to it what we figured out yesterday in class related to what the graphs of system of equations look like. So yesterday we saw ones that looked like this, where we saw same slope and different y-intercepts, right? What do we know about those? What kind of lines are these? These are parallel lines, right? Make sure we add that into your notes. And when they're parallel, how many times do these lines cross? None, right? So the way that we word that in math is we say there is no solution. So anytime that you see an equation that has the same slope and different y-intercepts, there's going to be no solution. All right? How about next to it here? We've got different slopes and different y-intercepts. So these lines intersect, so I'm going to put intersecting lines. And how many times do these two lines cross? Just once, right? We have one solution here. All right, and then now down below, this one almost looks like it's just a single line, right? But really, this is two lines that end up right on top of each other. They have the same slope and the same y-intercept. This is the same line. We call these coinciding lines. Your book may also just say they're the same line. It's like they're laying right on top of each other, right? Because they have the same rate of change and they cross through the y-intercept or the y-axis at the same point. So those are coinciding lines, or the same line, and so we would say that there are infinite solutions to this system. All right, and then finally over on the right side, we have different slopes with the same y-intercept, and these are also intersecting lines. Whoops, intersecting lines, and there is one solution. So basically, I'm noticing here, and you may want to highlight this in your notebook, when the slopes are different, these lines are always going to have one solution, right? But then if the slopes are the same, you have to pay attention. Oops, if the slopes are the same, then you have to pay attention to the y-intercepts to decide, are these lines going to have infinite solutions or no solutions? So use this as we work through the next few systems of equations so that you can find how many solutions there are without having to actually solve them. All right, let's take a look at an example. So here I've got a system of equations, and we're asked just to determine if it has no solution, one solution, or an infinite number of solutions. So I'm going to take a look at these two lines and first check to see, are they written in slope-intercept form? And yes, they are. If they weren't, we would want to make sure that we rewrite them in that way first. Well, now that they're in slope-intercept form, we want to take a look at their slopes. So on this first line, I see we have a slope of -2. And on the second line, we have a slope of 3/4. So I'm looking over here and I see, oh yeah, the slopes are different and the y-intercepts are different. And so that is going to be showing up right over here. Different slopes, different y-intercepts. Those are intersecting lines and they have one solution. Now, usually I'm going to ask you what that solution is, but for today we're just looking at how many there are. All right, let's take a look at another one. We're trying to determine if there's no solution, one solution, or an infinite number of solutions. The first thing I notice here is these are not in slope-intercept form, so I always want to be working with equations that are written in y equals mx plus b form. So first step, I'm going to have to rewrite these. So I'm going to start with this first equation, y minus 3 equals 2/3 x, and I just need to get this 3 to the other side so that I can isolate that y. And I have y equals 2/3 x plus 3. All right, so we got that one in slope-intercept form. Now we're going to do the same for the next one. 3y equals 2x plus 15. And on this one, I see I need to divide both sides by 3 so that I can isolate my y. And then I have 2x divided by 3, that's 2/3 x, plus 15 divided by 3 is 5. All right, now that they're both in slope-intercept form, let's take a look at our slopes and our y-intercept. So I notice right away both of these have the same slope. So we're going to be talking about a special equation. There will either be no solutions or infinite. So then we have to take a look at our y-intercept. Well, this first one crosses the y-axis at 3, and the second one crosses at 5. So we've got same slope, but different y-intercepts. And I see up here that is going to be a system that has no solution. They're parallel lines, and they will never cross each other. All right, for our last example here, we are going to, again, determine if there's no solution, one solution, or infinite solutions. My first equation's already written in slope-intercept form. If it helps you, you can put the plus 0 at the end to show that that actually goes through the origin. But our second one we need to work with a little bit here, so I'm going to start by subtracting 3x off both sides. And my new equation I have right now is negative 4y equals, I'm going to flip-flop it so my x's come first. So I have negative 3x plus 0. Well, I don't need to write plus 0, right? So I'm going to just leave that. And then I'm going to divide both sides by negative 4 to get y by itself and positive. And then I have negative 3 divided by negative 4. That's a positive 3/4 x. And again, it would be like having plus 0 at the end. It goes through the origin. So the two equations we're working with here are y equals 3/4 x plus 0 and y equals 3/4 x plus 0. That sounds like the exact same thing. Guess what? It is. Those two lines have the same slope and the same y-intercept, which means there are infinite solutions, or infinitely many solutions. Those lines, if they were graphed, would fall right on top of each other. All right, now it's your turn to practice. I'm going to put a couple practice problems that I'd like you to try in your textbook, and then submit your answers before you move on to the next item in the folder. Thanks for watching.